All right, good afternoon, everyone. Thanks for coming. My name is Ben Greenberg. Thank you for the introduction. And I will be talking about Hypermedia APIs. And the title is mobile, but this stuff does apply to web as well. So I work for Comcast. I guess we're with an international crowd here. Has everyone heard of Comcast? You know who Comcast is? So, Yeah, they have a, there's a reputation. So quick background, they're the largest cable company in the US. We do cable, internet, phone, home security, but the main product is TV. That's historically what we do. And so our current generation of that product is this Xfinity X1 entertainment operating system. So the centerpiece of that still is your television set. So there's a set-top box, but there's also a whole constellation of apps that go with that. So there are mobile apps for Android and iOS, and there's also a web client for that as well. And the whole premise of this operating system is that all the content on your TV is also available on your apps. So you can watch all your video on demand, you can watch all your live television, and also all your DVR recordings are in the cloud. So you can schedule a recording on your TV, and then you can go and watch it on your mobile phone later. So the actual API I'm talking about is what drives these mobile and web applications. So here's a real sort of bare bones architectural view of that. We speak to like dozens of external services, and we have this middleware layer that's fronted by the Hypermedia API. And then all our clients speak to that. iOS, Android, web, and then also some components of the set-top box also talk to this as well. So today we'll be going over this middleware and specifically the Hypermedia aspects of it. So just as quick background about what Hypermedia is, are you guys familiar with it? Has anyone heard of it, worked with it? So some. So we all know REST, right? REST is sort of like our default API choice these days. Get, post, delete, put, we know all those verbs. We know what they're supposed to do. Something that's lost, I think, for the most part when we do these APIs is that REST is not RPC. RPC meaning that you have a series of well-defined calls that are well-documented and then essentially hard-coded into your apps, which means I know if I want to get all the details for a TV series, I'm going to go to /TV series /ID. If I want to get the credits, I'm going to go to /TV series /ID /credits. If I want to schedule a recording, I'm going to go /this /recording and post that. That's actually RPC. If you have to code all those into your endpoint and you have to go through the documentation and look up how do I do this particular thing, what's the URL to do this, you're actually not doing the full portion of what REST really is. When Fielding wrote in his thesis about REST APIs and essentially invented them, one thing he said is that REST APIs must be hypertext driven. And that leads to this wonderful acronym, Hypermedia as the engine of application state, HADIOS, which I try to avoid because it's completely ridiculous. But so here's what that kind of looks like. So if you are doing true hypermedia, all you really have, or really the only URL hard-coded into your app is this URL to the homepage. And much like you might browse a website, you punch in the URL for the homepage, but then to find out all the content that's available, all the things you can do, you're going to browse links. You're going to click a link here and find a particular resource. From that resource, you might find out you can submit a form and do something with it. You might follow a link to get some more details about that. And you'll also see all the related resources. So if you're thinking about TV series, like the examples we're going to see here, you go to imdb.com, and you see a list of the top trending films, and you click a film. Then you click credits. Then you click an actor. Then you click a different film that he's in. That's all hypermedia. We're all used to it. But we don't really typically build our APIs that way. But if we're building a Hypermedia API, then we are. When you go to that homepage, what you see is a list of links to all the things that API offers. All the resources that it has, all the functions you can do, and then as you jump to a resource, you can see all the things that can be done to that resource and more details and all that, but that can happen inside an API, not just inside a web browser. And when we're building Hypermedia APIs, we talk about these things like the link relations and the forms and the state and all these things. We can put some structure on that. So there's a standard called HAL, the Hypertext Application Language. That was first invented by Mike Kelly in 2011. And that's just a really simple spec for putting some structure around how do we build Hypermedia APIs, how do we represent resources. It's typically in JSON. It doesn't have to be JSON, but that's what the draft RFC is, implementing that in JSON. And that's, so it's not a full-fledged standard yet. It's in draft 7, so it's getting there. It's getting close, and it's definitely getting some traction in the community as well. So in HAL, what that does, like I said, is it defines structure to an HTTP resource. So what we see here is on the top left in that orange section, that's our resource state. So those are just plain JSON properties like you're used to. Strings, integers, arrays, and that kind of thing. Just plain old JSON. Then we have links, and links are sort of the core of what makes this hypermedia. Those are the relations between resources. And that could be a particular related resource. It could also be something that can be done to that resource, which would then combine with an HTTP verb to make that do something. And there's an extremely important link that is required in HAL, which is the self-link. Because when you're dealing with REST, all your resources have to be identifiable. So there has to be some kind of URI to identify this particular thing in the space of the entire world, I guess, for URIs, right? So you have a host name, and then you have all your different resources there. And so that's going to be in your self-link, which if you're on a particular endpoint would typically be what you would paste into your browser or call out to get that resource back. So if you're looking at a resource, you could follow that self-link, and you would get the same resource back. But besides just linking to resources, you can also embed them. So you can choose to link to a resource so that a client of your API can say, hey, I'm interested in the credits for this TV series. Let me follow that link. But we also could decide as sort of a courtesy to our clients that, well, rather than make them make that round trip to get the credits back, why don't we embed the credits in as a full-fledged resource? And those are, so it's entirely recursive, essentially, or it can be, in that you have a full-fledged resource with state and self-link, with links and a self-link, and within that, you would have more resources that also have a self-link to be considered valid HAL resources. So a quick look at how that looks in JSON. So this is Silicon Valley, the TV series. And you can see here at the top section, this is our state. So plain old JSON properties, just how you would expect. Title, content rating, release year, of things that represent the state of this object. But then we have this underscore links property, which is part of the HAL standard. And this is how we define the relations between resources in the API space. And we have that self-link that I talked about. The profile here is also something HAL supports, which defines what type of resource something is. And so if it's the self-link, it's describing the resource itself. If that profile is on a different link, it's describing what the thing you're linking to is. So in this case, we're saying, hey, this thing's a TV series, so that our clients will know what type of object this is. But that's not actually required, but it does turn out to be very useful in practice. And then we have our actual link itself, /TV series /12345. If you plug that into your browser, you would get back all this JSON. So it's just identifying itself. And then we also have this credits link. So you could follow that link, and you would get all the cast and crew of this particular TV series. But then we also have the ability to do these embedded resources that I talked about. This is also a reserved property in HAL, _embedded. And in this case, we're embedding all the episodes that air for this particular TV series. So we have a list of episodes here, and these, just like its parent resource, have its state, title, season, and end episode, and then also has the underscore links. And because it's HAL, also has its own self-link, where we tell you, hey, this thing's a TV series episode, and if you wanted to get the details of this particular episode, you could follow that self-link. So by embedding it, we are letting the clients not have to make that round trip, but if they did want to get back just that particular resource, they could follow the link and get back just that one episode, not embedded in the parent, as you see here. And that's just highlighted there. So that's the background on what Hypermedia and HAL are. So here's, I guess the question is, why did we choose to go down this road with our API? So we knew we wanted to do HTTP and JSON. That's pretty standard these days. Those things are very well understood. We like the caching semantics of HTTP. All our other services are. There's lots of good client libraries and server libraries for that. Same with JSON. It's good for machines to read, or pretty good for machines to read. It's very nice for humans to read. That's standard for us to build our APIs that way, and that's pretty standard in the industry. We knew we wanted to do a resource-oriented API. That just makes APIs easier to reason. When you don't, it's one thing to get like a spec from the product team and say, here's how this thing should look on an iPad. And if you try and build your API to draw that particular screen, you're going to pretty much end up in a mess. It's much better to think about, okay, what are the components that this particular endpoint needs? A TV series, a list of people. And when you start thinking about things as resources, things like caching become a lot easier to reason about, and you also get all the benefits of HTTP really using it in the way that it was intended. Also, discoverability and self-documentation are key parts of Hypermedia. What that means is that not only does your API just go to that homepage and essentially browse the API, you can do that yourself in your browser. And in fact, for our APIs, they are JSON, but there's also a mode to view them in HTML, which means that you can go to the homepage and the links, like those underscore links, they're actually just clickable hrefs or like anchor tags in HTML. And that's really useful for developers when they are learning a new API, and even for support teams to go in and see why something's not working right, and even product people can go in and see the kind of stuff that we're sending down to our clients. And as part of that, you get self-documentation as well. I mean, I don't think any API is truly self-documenting, but this gets pretty close. You can go and look at the API and just at a glance see all the things that it does and all the information that is there. And then one of the key things for us is evolvability. So we don't version our APIs. We don't need to with Hypermedia. We can change URLs without breaking our clients. We can change the way things are called without breaking our clients. I mean, there's definitely a contract between us and our clients, and if we change some things, we will break. But there's a whole lot that we can change without breaking clients in the field. And for us, we deploy every day. So it's really important for us to be able to roll out features quickly, not break all the old versions of the iOS out there, and also not break our devs who might be developing against something that we deployed last week. They're rolling out something new. We want to be able to constantly evolve that and not break our clients. And then finally, one client to rule them all. The idea here is, why HAL? We have multiple Hypermedia API teams inside Comcast, and what we would like to do is have one client that understands HAL. So yeah, we could do Hypermedia in different ways on different teams, but having a single client allows us to share code and get reusability and that kind of thing. So that's our sort of the technical side, but then we also have on the product side how this thing should work for the customer, right? So typically we would want to minimize our round trips. We want to deal with non-persistent connections. We want to support a responsive client experience, meaning that we don't necessarily want to just dump down what looks and feels like a web page. It's pretty easy in Hypermedia to sort of push down what looks and feels like a 1990s like Yahoo or something. Like, oh, here's a list of things. Click one, wait, load. Tap one, wait, load. That's sort of what it lends itself to, which is pretty good for CRUD operations if it's more of a backend API, but for dealing with an actual app, you actually want that to look and feel fluid and like a native application, not like a website. And then also, we were driving parts of the UI through this API. So that means we want to be able to change how forms look, how things are labeled, how things are laid out on the API side so that things can be changed in one place and then affect all of our clients on all of our platforms. So those goals don't always jive with Hypermedia, sort of like textbook Hypermedia or HAL. So what I'm going to go into is a couple examples of how we dealt with that. So first example is improving cacheability. So here's like a little demo of our app here on an iPad, and all we're doing here is we're just browsing available TV series, going with our same example here as before. So we found Silicon Valley, we're tapping into it, and we're loading what we call the entity screen. So we're seeing here all the episodes that are available for this show. Those are things that you can watch now. Here's the details, little description, poster art, and then here are the upcoming listings, meaning things that are airing on TV in the future. So if we are designing that in the Hypermedia API using HAL, what this thing might look like is this. You have your resource state, which is all the stuff you need to display there, the title, the description, when it came out, all those things, and then all the related things that the client is going to show. So that's the episodes, the VOD showings, which is a video on demand, things you can watch right now, and then the upcoming listings. And then there's also the self-link, because there's always the self-link. So that's the identifier for this particular resource. So we can hand this off to our clients and say, hey, here's all the stuff that you need to draw this entity screen. You have all your state, and then you have links to all the episodes, to all the VOD, the video on demand, all the listings. It's all there for you. The first thing they're going to do and come back to us and say, that's great. I don't want to make 5 calls to draw this page. When I'm on a mobile phone or even on a browser in my house, I don't want all those round trips. It's not efficient. So because we can embed resources in HAL, we can say, fine, we're going to not make them links anymore. We're going to just fully embed the full-blown resource inside of this TV series. So now when the client pulls this down, they're going to get the TV series and all the episodes, all the information about those, and all the on-demand showings, and all the upcoming listings, all in one shot. That's great, but there was a big difference here when we had this versus this, because when we had this thing is really, really cacheable. The title, the description, the year, that stuff doesn't change very often, if ever. So our TTL on this thing could be like probably even a day and we'd be fine. And it would probably 304 on a conditional request for like a month, meaning super cacheable, really good for our clients. With the drawback being that now they have to do all these round trips. So when we do this, now all of a sudden, this thing is not so cacheable anymore. We have episodes that are coming out every week. We have the on-demand showings that go in and out of window. We have the upcoming listings that are also changing all the time. So now this thing that probably didn't change for a year is now changing at least every week, if not more. So this thing is no longer as cacheable as it was. But it gets worse than that because these things actually have recordings on them. So I talked about how we have the cloud DVR functionality. So what that means is that for each episode of the show, you might have a DVR recording of that. For each upcoming listing, you might have a scheduled DVR recording of that. And these things change frequently, or they can change frequently. So I could be on my iPad, and my wife's downstairs, and she schedules a recording. That thing should show up on my iPad the next time I go to that entity page. So we might, in this case, make a compromise with our product guy and say, hey, yeah, this stuff could change, but what can you tolerate? How much delay can you tolerate between when my wife schedules a recording and when it shows up for me on my iPad? And we might come to a conclusion that, okay, it's okay to wait 10 minutes, it's okay to wait 5 minutes, and we'll put a TTL on this thing of 5 minutes or 10 minutes, and it'll still most likely 304 when you call it because I'm not scheduling recordings of every show all the time, right? So that's okay. But if we actually dive down into what an embedded recording looks like, right? So now we're looking at these like little recording guys here. We're looking at what, we're zooming into one of those. So this thing has its own state and its own self-link, of course, because it's a hypermedia resource. And it has its recording status. Okay, it's scheduled, it's in progress, whatever. It also has the resume points. And that's because one of the product requirements here is that I want to be able to watch a DVR on my set-top box, pause it, go upstairs, open up my iPad, and continue right where I left off. So now we've gone from having this resource here where, hey, I have to be concerned that someone scheduled a recording, my kid scheduled a recording, and I want to be able to see it, and maybe it's okay if I wait 5 minutes to see it, to dealing with these resume points that are changing every 10 seconds, right? So we can't wait 5 minutes because if I pause my DVR, go upstairs and try and finish watching it and it jumps me back 5 minutes, I'm going to be pissed as a customer. And the product guys aren't cool with that. So how do we deal with that, right? We've come to a compromise where we can cache this thing for 5 minutes. It's not good enough for these resume points, which is my progress in the particular recording. So looking back again at our embedded recording resource, we have the resume points here as a resource state. What we can do is we can promote that from simply a JSON property to a full-blown resource itself. So now all these resume points are full-blown resources, and because they're resources, they have self-links, which are identifiers. And in this particular case, the self-link, you'll notice, is not a URL, it's a tag. So that's still a valid URI. It's not something that's navigable. You can't type it into your browser and get anything back, but it's still a proper identifier for what this resource, to identify this resource in the space of our API. So since these things are now full-blown resources, we don't have to embed them. We can just link to them. So what we've done here is we've taken our recording and we've linked to all the resume points for this particular thing. So now this thing is more cacheable than it was. We don't have these constantly changing resume points on them. But we also don't have the resume points on them. So how do we reconcile that? So what we did in this case was we created a new endpoint, which is called /resume points here. And all this is like a container resource. So it's a full-blown HAL resource, has a self-link, which is its URL, has no state, but has just this list of embedded resume points in it. And those resume points have their identifiers, the self-links on them, so that when the client now can call out to two endpoints to draw the entity page, it can call out to get all the data except the resume points. They can call out separately to get the resume points, and then marry those together based on those tag identifiers. So what that looks like real quick in JSON is that for looking at our TV series here, we've embedded the episode, and we've embedded the recording inside the episode, and the recording here has has the link to the resume point. So all that is that tag URI. And then we have our /resume points endpoint, which is just a container, and I don't have the whole thing. I don't have the whole thing here, but what you can see is there's now these two embedded, full-blown resources that just show you the position. So we have the self-link, so we can identify that resource, and then we have the position, which is how far into that particular program you've watched. So what that means is now, when we are drawing this Silicon Valley entity page, the client's going to make two calls out. If we're lucky, most of the time, the one out to that entity screen is going to 304. The call out to resume points is changing much more frequently, but that's also a smaller and much easier to parse endpoint. So we've extracted the most uncacheable thing from our resource to make this thing more cacheable and faster. So the trade-off is you're making two calls, right? When we first came into this, it was going to be 5 or 6. Client said no. We essentially compromised with 2. But like we said, one of these is likely to 304. And also, these can be done in parallel. So the client can draw that entity screen before it has the resume points. When the resume points call comes back, it can layer that data in, so it's ready. So driving a responsive mobile UI, and this also applies to web. It's exactly the same for us. So I have a quick demo here as well. So in this case, we're browsing all your TV listings, your grid that you'd see on your set-top box. And so we're scrolling down all the way to see all 1,500 channels, whatever the heck we have now. And this thing goes out 2 weeks. So now we're scrolling all the way into the future, days at a time. And I don't know if you guys can see it on there. I think you can. So when we scroll, we don't have all the data loaded, but we do have that grid still painted in the background. And I don't know how easy it is to see. Besides just the rows, we also have the vertical lines that are indicating when the programs start and stop. And the idea here is that as soon as this thing loads, as quickly as possible, we want users to be able to fling their device to see all the channels and 2 weeks out without having to wait for all that data to load. So the first kind of obvious way to do that is that we would just push down all the data in one shot, right? So what would that be? So let's say we have 500 channels conservatively. It's about 1.2 kilobytes of data for each channel. That's like the call sign, the logo, all that, like the link to the logo, all that kind of stuff that's required to tune it. So we're talking about 600 kilobytes of data just for that list of channels, that like y-axis. And then when we actually get to the listing data, we can say conservatively, there's 25 shows on per day on each channel. At 500 channels, that's 12,000 listings per day. The product requirement here is that we would need to show 2 weeks worth of data in that grid starting out. So that's 168,000 listings for 2 weeks. This data is small. It's only 397 bytes per listing, but that still gets us 63 megs of listing data, which is not feasible to push down in one shot to the client, right? I mean, that's uncompressed, but even so, it's just way too much. So we had to figure out some way to break this up, right? We wanted this quick, snappy response. We wanted that thing to be scrollable really fast. So here's what we came up with. So we broke this thing apart into 3 different calls. The first one is the channel map, and that is just the list of channels that are available to you. So we made a resource called a channel resource. This thing, of course, has a self-link, and again, here we're using a tag, not a navigable URL, but a tag URI to identify this channel. So in this case, the example is HBO HD. And so you're going to get back all 1,500 channels, whatever you have, all in a single call. And that stuff doesn't change very often. It's not very often that your channel lineup changes. It does change, but we're talking maybe a few times a year. Then we have what we call the grid shape. So the grid shape is what I hope you were able to see is all the boundaries of when programs start and stop. So we have a resource here called time offset channel group, and all that really is that it looks something like this. So if we're looking at for one particular channel what these start time offset seconds are, so let's say it's 10:30, and we pull this list. So if we're looking at like -848, that means that thing started maybe at 10, so it started in the past. And then the next program starts at 951 seconds from now. The one after that starts at 2,751 seconds from now. So what that is that's if you're imagining a row of the channel grid, it's when the program starts, when it stops, and the next one starts, when it starts, and the next one starts. So that's enough information to draw just not the listing data, but all the lines that are the background of the grid. And we have so those are all standalone resources that then link back to the channel, and you can see the link here. So it references the channel from the channel map using its tag URI. And then finally, we have a call called listing chunks, which gives you back a chunk of listings. And so that's, again, we have these resources called TV listings, and this is just a whole dump of listings, basically. And it doesn't really matter the order because they have their start time and they have a link back to a channel. So this also references the channel resources that we got back in the channel map call. So what the client can do is it can, in one shot, download all the channels you have available. It can download all the information to draw the lines of the grid, and then it can separately call out and get the first 4 hours of listings, the next 4 hours of listings, the next 4 hours after that. So what that looks like is that when you first tap on that link or tap your screen to get to the channel map, we're going to get 3 calls out. We're going to get that channel map. We're going to get the shape of the grid for 2 weeks out, 336 hours, and then we're going to get the first 6 hours in this example of listings. And once those calls are all done, so we're looking at 600 kilobytes for the channel map, 1.3 megs for the shape, and 1.4 megs for the first 6 hours of listing. It's still a lot of data, but compressed, it's not nearly as bad as it was. And that channel map, again, changes a few times a year. It's probably cached. So even if we make the call out, it's going to 304. You don't have to download any data most of the time. So you're really only dealing with that 1.3 meg and the 1.4 meg, which is also uncompressed, again. So once you have these 3 calls coming back, you now have enough information to scroll the grid all the way down, to look at all the channels, and all the way to the right smoothly, and you're seeing those lines kind of whisk by you as you scroll 2 weeks out. Then when the scrolling stops, then the client's going to make a call back out, and it's going to get the listings for that time that you stop. So if you scroll 3 days out, when you stop, it's going to get the listings for that time. So you're going to see a loading dots for like a split second while we get just the listings that are on your screen at that time. And then even when you're browsing, you can just keep going. The client can just keep calling 6 hours at a time, getting more and more data in the background and kind of guessing where you're going to go. All right, so for the next section, I'm going to go over some extensions we made to HAL. So the big one is forms. If anyone's ever looked at HAL, one of the things that's kind of notoriously missing from it is forms. So yes, there's links. There's not a concept of forms as you have in HTML. And there's a strong case for that. That was a very deliberate decision when they designed HAL. It was to try and keep it as simple as possible, and it was also because in many cases the verbs or like what they do is sort of intuitive or can be intuitive depending on the API. So if you're dealing with a typical CRUD situation, you might know it's like, okay, hey, this thing links to a person, a credit links to a person, and I know that if I post to that, I'm going to create one. I know if I do a put, it's going to update it. I know a delete deletes it. It's sort of logical, but that's, for us, very limited because when we are looking at resources, our clients don't typically create or modify data. They simply consume or perform actions. So if you have a link on a TV series that says, schedule me for a recording, it's not clear whether that's a get, a put, a post. The clients would have to bake that in. And for us, that's sort of against the spirit of hypermedia. So what we did was we created an extension that allows us to do forms that are heavily inspired by HTML. So the example here is you're looking at Ghostbusters 2 on your iPhone, and then we have all the things you can do with this, right? So you can watch it. That's a get. That'll tune you to the channel it's on or start playing the on-demand content. There's the more info that goes to a detail screen. That's a get. So those are links. But then for the record, rather than make it a link, we made it a form. So what we created was this underscore forms property, just to kind of go with the spirit of HAL. And essentially, we've taken an HTML form and JSONized it. So we can tell the client, hey, when you're doing this action, right? So the client knows the name, schedule recording. But that's really all it knows. It knows that there's an action called schedule recording. It's something that changes state. And we tell it what the method is. We tell it which URL to post to through the action. We give it a title if they want to show that to the users. And then we put fields on it, same as you would in HTML. And we also have field type, just like HTML. So here we've made all these hidden. And that's because for this particular use case, what's supposed to happen is when the user taps record, there's no prompt, there's no modal, it just happens. And what happens when the user taps that is that the client knows to submit the schedule recording form. And at that point in time, it says, hey, it's a post, here's where I put it, and here's the data that has to go in the body for it. So we can change all this stuff without clients changing. So if our default values need to change, we can change that on the API side, and clients will just automatically get that update. If we need to include some extra fields, maybe in certain cases or not, that also has to go here as well, and the clients don't have to change. All they have to know is, I submit scheduled recording, and it does this action, and all this stuff can change to our heart's content on the API side without having to update the client. So that's actually more powerful when we look at something more complex. So if we're scheduling a complete series recording, in this case, we do want to show a modal to the user and give them all the various options that go along with that. So that's, okay, do I want to do only the new episodes or the reruns? How long do I keep the recordings? Which episodes do I start a few minutes before the scheduled time? Do I end right when it's scheduled to stop, or do I go further, HDSD? Those are all options that we want to show the user. But as I talked about before, we want this stuff to live on the API. So for that, all this stuff can be fields, just like we saw before. So we can push these down just as selects, just like in HTML. We can change the options, we can change what they look like, we can change the text, all on the API side, and the clients just work for that. It's also really powerful with hidden fields here, because if we're trying to promote some kind of default behavior, which might be dependent on a scenario, the clients don't have to know that. All they have to do is know, hey, I know the name of this form, submit the form, and all the data just comes back to us. So there's a very good example of the power of this with a bug that we had. So here we're looking at your list of scheduled recordings, which are grouped by what TV show they are. So these are all the shows I have, Louis, Cosmos, whatever, and then how many episodes I have recorded. So this first one, Workaholics, I had 57 episodes. I should have stopped the recording a long time ago. It's taking up all this space on my DVR. Just delete it all 57 episodes. So the way that form looks in HAL, in our extension, is we have a form called delete group. Clients know about that. That's all they know. So when we first built this, we instructed them, send a delete to this endpoint. And then we, on their behalf, put all the IDs of the recordings as query parameters. So that's why you see all the rec IDs over there. So for 57 episodes, we were doing rec ID equals 1, rec ID equals 2, rec ID equals 3, 57 out. And what happened was, when someone had a whole lot of recordings, somewhere something in our infrastructure was truncating it, so that meant that only 30 episodes are getting deleted. They'd come back to their screen and still see a bunch of recordings left and be like, what the heck, right? So for this particular bug, we were able to fix this purely on the API side. We just changed what kind of form this was. So rather than making a delete, we turned it to a post, and we put those IDs in the body. So that's like a typical way to solve this problem. In this case, the client didn't have to know anything about that. All we had to do was change the form as we sent down to the client. Client submits the delete group form. It has a hidden default field. It sends the data, and it worked. So that's powerful for us to be able to have a bug come out in production, be able to fix it a day later, have it work across all our versions in the field, and not have to version anything or push out a new client release or anything, and be able to change stuff really, really quickly. So that's all the examples I have. I have a few takeaways and some parts of a summary here. So some of the stuff I didn't go over. I'll just go touch on really quick. So when you're building really any JSON API and Hypermedia, always use gzip compression. It sounds obvious, but I've seen many, many APIs where someone just forgets to turn it on the server or on the client, and you're wondering why things are slow, and it's because someone didn't turn on gzip support. It makes a huge, huge difference, especially with JSON, which compresses really, really nicely. Also support e-tags. That's pretty easy now on the server side. Yes, you can get very fancy with e-tags. You also can just hash your output and stick it on the e-tag. And then with that, if they're using a modern client on the client side, it just works. You get free support for conditional requests. So that's important. And then also, always set your cache control headers. That's something that really pays to be disciplined about, because it really sucks to have to do that later and have to figure out how long something's cacheable and that kind of thing. And when you start thinking about how long something is cacheable from the beginning, you will design better APIs. You will avoid situations where you end up embedding something or including some piece of data that makes your thing not cacheable. On the same note, back to the first example, be aware of what happens when you embed resources. You're very likely to change your cache semantics. So just because clients want everything down in one response doesn't always make it a good idea. There's some compromise there. So that means you can break up your resources in line with how cacheable they are, and then you also can componentize your resources to allow clients to draw the UI while they're getting additional data. So that's like the channel grid example, and also like on the entity example with resume points. You don't have to have all the data to draw the screen. It's okay to put what you can and then fill in data as it comes in, which also helps for fault tolerance as well. And then finally, with forms, as you saw, we can add a whole lot of flexibility to our forms as well. So that's all I got. Any questions?